All right, let's get started. Hello, everyone. Welcome to the MIT Mobility Forum. This is the 175th session. It's a great pleasure to have Chris Urmson join today. Until recently, no driverless truck has hauled commercial freight on U.S. public road. As of today, Aurora is running them daily across Texas, New Mexico, and Arizona, over 250,000 miles without incident. Chris, you probably can update us the number now, probably a few more thousand miles driven here. But what does this evolution from a theory and a promise to the practicality and the delivery actually look like, right? What does it mean for the future of freight system? So it was really a joy to have Chris Urmson join us today, who's co-founder and CEO of Aurora Innovation. Beyond Aurora, I would say Chris is really instrumental to the whole autonomous driving industry, both from the science, engineering, as well as to the business. So today we'll roughly explore about three different areas, from the science technology to economics and business reality, and to the policy society entrepreneurship. So Chris, welcome to MIT.
Yeah, thanks for having me.
Wonderful. So it seems, I think from the outside, we see there's really three distinct phases of your career here, right? At Carnegie Mellon, you led the DARPA team, won the urban challenges, then spent 8 years building the Google self-driving car, now today's Waymo, and then co-founded Aurora in 2017 to bring self-driving technology to market there, right? So give us a little bit about the detail about the transition. Maybe start from the first one, when you transition from CMU DARPA to the Google car, what brings you from a research to Google here?
Weather. No, I had when I was in high school, my dream had been go to a Canadian university, go to a top tier U.S. university, and then become a faculty member. And so, I had the privilege of getting into Carnegie Mellon. I think they made a mistake on the admissions. I got to spend some time there, and then ultimately got to the point where I had a faculty job. And it had been after doing the DARPA Grand Challenges and Urban Challenges, which are ancient history at this point, 20 some years ago, but they were at the time, these big idea was you could get a vehicle to drive across the desert at speed, and nobody had done it before.
Mm.
And that was exciting. And we ended up doing quite well at that as a team. And then I got approached by Sebastian Thrun, who was at Stanford and Google at the time, about, hey, we should do something together. And then ultimately that evolved into, hey, Larry would like to do self-driving cars. Well, except that wasn't the word, automated cars or something. We didn't have the word self-driving car at the time at Google. And, my wife and I had just bought a house. We'd settled in to Pittsburgh, great friend network, amazing job at the university. And it seemed like a big risk, right? This is 2009. So at that point, I think the iPhone had launched a year before, and Android had launched that year. And Google didn't have Chrome yet. It was just a search. And so the idea that this web page would want to do automated vehicles seemed crazy. But it was, it was an alluring opportunity. And my wife and I thought about, okay, if we're going to go try something like living with the crazy people in the Birkenstocks in California, this was the time in our life to go do it. And so we packed up and moved over there. And it was, I look back at my career now, and while that was a very difficult decision going in the forward time direction, the backward time direction was clearly a no-brainer. And being able to go to a place where the university environment, Carnegie Mellon, was phenomenal, but where we had the resources to really do what I was excited about, which was take this technology and translate it into something practical.
Right.
It was just an incredible opportunity.
We lost a professor, but we get an AV industry coming out of this, right? That's
Yeah. And I really, I couldn't say enough thank you to, Larry, Sergey, and the Google folks, right? Because if we again go back 20 some years now, the Defense Department through DARPA funded those grand challenges, and it really created a lot of energy in the space. But DARPA's mandate is to get stuff to 10 to 20 years out and then hand it off to industry. And at the time, 2009 was not a great time for industry to be investing long term, right? It was a bit of a financial mess. And so for Google to be willing to kind of take a flyer and invest what they did, and initially it was for their budget, a trivial amount of money, but for a university or most places, it was a significant amount. And then it actually did. It's kind of between the investment DARPA made and the investment Google made, I think it created a whole industry, which is phenomenal.
Right. Yeah. And then for the second transition, what brings you out of Google and started the Aurora?
Yeah, well, at some point it's time, right? I had been at Google for many years, and it was a phenomenal opportunity. I got to work with some of the best people I've ever worked with in my life. Still have great friendships with those folks, and awesome resources. But at some point, I didn't agree with some of the decision making that was happening at the company. And I have a belief in business. You have three options. You can try and fix something you don't like, you can
Mm-hmm.
get in line, or you can get out of the way. And I tried very hard to fix it. And it was hard for me to kind of buy into some of what we were thinking at the time there. And the company and the team deserve somebody who did. Right? That at the time I had 600 and something people reporting to me, and if I didn't believe what we were doing, I needed to get out of the way. And so I ended up stepping away from Google and spent some time trying to figure out what to do. It was very flattering, right? I had a lot of people that were interested in hiring me, and ultimately um,
Monday.
thought about kind of what would minimize regret, right? I had been doing this great stuff with Google and loved it, and thought, I had conviction that automated vehicles were going to be a thing. And I didn't want to be telling my grandkids, I could have been a contender, I could have been part of that.
Right.
And thought, okay, I can go and try and start a company
Right.
where it'll either go really well and it'll be a happy ending and I'll be excited about it,
Mm.
or it go really well and I don't enjoy it, in which case I can just get out of the way again, or to go badly and I'll know, right? And I
Right.
won't have regret of like what could have been. And so ultimately ended up starting this, had two amazing co-founders in Sterling Anderson, and
Right.
MIT grad, though we try
Oh.
not to hold that against him.
Right.
And Drew
Right.
Bagnell, my colleague from Carnegie Mellon.
Right.
And it's been an amazing, I guess now we're at 9.5 years.
Right. Right.
And
You,
so
you started this when you were 40 to become entrepreneur? Or
yeah, something like that. Yeah.
right.
Yeah, right around then. Yeah.
I see. Yeah. And then within Aurora, when it was first founded, it targeted as a general purpose self-driving system, right?
Yep.
Then you start to really sharp the focus on trucking. What lead to that decision?
Yeah, so we continue to be building a general purpose driver,
Mm.
but the application we're choosing to go after first is trucking. And
Right.
so talk a little bit about the background of that. So we started working with light vehicles, frankly, because it's easier, right? That just operationally, a car costs a lot less than a truck.
Yeah.
You can fuel it all over the place. You can fit in smaller spaces. You don't have to have a very special driver's license to operate them. It was just operationally easier. And then added to that, at the time, we didn't think the technology existed to see far enough down the freeway to truly do level 4 driverless automation.
Mm.
Um, and this is born out of some of the experience I had at Google, where most of the time when you're driving down the freeway, it's quasi steady state, right? We're all moving about the same speed, and so you don't actually have to see that far to interact with the vehicles next to you. The problem comes if there's something rare that happens, like a vehicle stopped in the freeway
Yeah.
and you're the first to encounter them. And there you have to see that at a very long distance to be able to react with a rational amount of braking or avoidance maneuver. And so in Google, we had done experiments on this, and we kind of come to the conclusion like, ooh, we don't know how you can see that far yet. And of course, there's been some breakthroughs. And so at Aurora, we said, okay, it's easier to operate light vehicles to begin with. We ultimately want to operate all vehicles, but now we don't know how to solve that. So let's focus on kind of building the core competence. Meanwhile, I spent a couple of years with one of my colleagues here trying to find the technology that would actually unlock high-speed driving. And we ultimately found this in this little company in Bozeman, Montana called Blackmore.
Yeah.
And what they had been working on is for the, 10 years, 15 years before that on frequency modulated continuous wave LiDAR.
Right.
And we can get into that at some point, but it basically unlocks the ability to see further down the freeway.
Yeah.
And at that point, we said, okay, we've got this basic driving capability. We now think we have a unique ability to see far enough down the freeway to solve this problem. And the business of trucking was a much clearer, more compelling business than the ride-hailing business. And I credit Sterling for that. He was a big champion for like, this is actually the place where we can go build the most interesting
Wow.
business. And so that's where we've been.
That's interesting. So I just about to ask you about the technology side. This frequency modulated continuous wave is one of the questions I asked you, but I didn't appreciate that this is actually one of the reasons that trigger you getting into the freight industry as one of the motivation there, right?
Yeah, because we thought we had kind of conviction that trucking was going to be a big and important market. We should go win that market. But we didn't believe at the time, this was 2018, 2019, 2017, 2018, that you could literally that you could see far enough robustly to trust a 70,000 pound thing driving at 70 miles an hour. And so this technology was a fundamental unlock for us to go and go attack that space.
Is it compared to a regular LiDAR, so it can measure both distance, but also the instantaneous velocity through the Doppler effect here, right? So what does this kind of engineer advantage mean for the truck driving here? Well, why is it a big deal here?
Yeah, it's a big deal because I mean, if it's interesting, we talk about the technology, but I can tell you about the product advantage is we can react to things or begin reacting to things somewhere between 11 and 20 seconds now sooner than you can relying on conventional LiDAR. And that is the difference between oh crap and oh.
We can handle, yeah.
Like, and it's at the point now where we are seeing things, particularly at night, the LiDAR is reacting, allowing the vehicle to react to things before our operators on board the truck are able to see them. And so we're making and originally it was, why is it making that lane change to, okay, it's moved over. What was that? Oh, there's a guy walking down the side of the freeway, or there's a vehicle parked on the side of the road, and we've just moved over and made space for it before the person in the truck is able to react to it.
I see. Yeah. So beside the sensing technology, this FMCW, another important thing is the kind of intelligence core here, right? There is, of course, the pivot from symbolic logic base to, first of all, perception start to adopt machine learning, then to the whole end-to-end foundational model. Give us a sense of the architecture design that Aurora has
Yeah.
here.
Yeah. So if you go back and look at some of our white papers from 2017 that we published, we talked about the importance of having a data-centric approach to developing this technology, right? That you can build engineered systems to allow you to bootstrap to the point where you can gather data from the environment, but you need to be purely, to the degree possible, purely data-driven. And that, it's clear that AI and ML are going to play a huge part in the success of this technology. And I think we've maybe undermarketed ourselves on how we've approached that. But where we are, the system we've developed today, we've branded Verifiable AI. And the idea here is that in many ways, what's happened in the large language model field is, well, it's not many ways, it's just fundamentally mind-blowing, right? It's incredible what's happened there, and things that I wouldn't have believed possible 5 years ago are now certainly real. But those applications have the benefit that in general, there's a person that can intervene between, the generation and the execution. And, the kind of the canonical example from a couple of years ago is, if you ask the LLM, I think it was Gemini, you asked it, how do I keep the cheese on my pizza? It told you to put glue, right? And, any rational person would say, that's a dumb idea. Okay, try again. The equivalent at 70 miles an hour will be a disaster. And even today, with the incredible advances that these systems have made, I think, the last version of Gemini was released where they were proud that they had dropped the hallucination rates to, 40%, right? And when you think about the diversity of what we encounter in the real world, we just can't bank on that by itself. And so with verifiable AI, there's two important concepts. So one is we decompose it from one kind of homogeneous model into, in our case, fundamentally two models, a part that's seeing the world and a part that's responding to the world. And then we create an interface between the two that defines kind of how do we want to understand the world, and then how that's expressed to the part that's reasoning about it. And this loses information, right? Because the expressivity of the first model is limited by that interface that you've created.
Right.
But importantly, it forces the action to respond to things in the world that matter. And it allows us to create a testable system. And so maybe let's talk about that. If you think about these two parts, understanding the world and reacting to the world, they're both exponentially complicated. And if you smush them together into one system, you now have the product of exponentials. Right. In contrast, if we are able to thoughtfully decompose them, we have two exponentially complicated systems, which verifying and validating that is literally exponentially easier, kind of by definition. And so that's an important concept, because we're not just trying to make a thing that looks like it drives or seems to drive well. We want to, before we put it on the road, have conviction that it drives well. And that means that designing for testability is actually an important part of this.
Right.
The other part of this is that these large models are so complicated, our ability to truly understand what's happening in them is still limited. And I point to, because the folks say, oh no, just put it in one model, and what we'll do is we'll take heads off, and we'll train to make sure that it understands the concepts of cars and pedestrians and whatever else it is that we have part of that interface. The contravening concern around that is that if you look at some of the studies on how these models, these reasoning models operate, right? And the idea is like, show your work, so I'll understand what you did. What we're seeing is that they will actually not always describe how they got to the answer. They will provide a description of how they got to the answer that feels compelling, but is not actually the process they did, right? And so the parallel here is that just because I trained heads that would get the model to have certain concepts doesn't mean, certainly doesn't require, that that is how it's actually understanding the world and how it's reacting to it. And so for us, making sure that we know how the thing works, to a level of resolution is critical, and then being able to test and validate it and have conviction of how this works.
Right. When you separate the two, you force information bottleneck in the model. It forces the compression, therefore, hopefully develop some structure that human can interpret and verify in there.
Yeah.
Yeah. Great. Thank you. Yeah. So the plenty of other question on science and engineer, but let's leave some time for the business side and discussion here, right? So first of all, tell us the status quo here, like which routes are you operating, how many trucks, how long it is. Yeah, give us some basics there.
Yeah, so and we are in a quiet period, so I'm not going to be breaking any news because we're a publicly traded company at this point, so there's only so much I can say. But what I can tell you is we started last year in April operating a truck between Dallas and Houston in good weather in the daytime. And over the course of the last year, we've expanded the conditions in which you can operate. So we operate day and night. We operate in the rain at this point. We also expanded from Dallas to Houston to Fort Worth to El Paso, Fort Worth to Phoenix, El Paso to Phoenix, and Dallas to Laredo. And so it's been a really exciting year for us. And it's going to pale in comparison to how exciting 26 is. So we've started 26 with a handful of trucks operating on these roads. Over the course of this year, we're going to end up operating a couple of hundred trucks. We're going to be operating them across the Sun Belt, serving customers and, hauling freight as we have been for the last several years for them, and providing value from this technology.
Well, give us based on the economics, like cost per mile comparison, the hour of services they can do, or the actual transit time that you factor to the customer.
Yeah.
How does it compare?
Yeah. So maybe I've got to be a little careful here, but I can tell you how we talk about it. So when we think about the value to customers of automated trucks, and our customers are the trucking companies.
Mm,
So companies like FedEx, Werner, Hirschbach, Schneider, Detmar. These are companies whose job is to own trucks and haul stuff for other people. So the values we see for them. So first is a safety benefit. For every one of these companies, safety is first. The fact that the Aurora driver is never distracted, that it has 360-degree field of view. Something that's underappreciated is that it's actually able to provide equal attention around the vehicle. So I think of an example. I was on a truck, or one of our trucks was driving down the freeway, and we came to a point where the freeway separates. And there was an 18-wheeler parked on the gore point with the driver had got out onto the side of the road and was, I don't know, checking the load or doing something. Terrifying place to do it. And so as a person looking at this, my attention is focused on that. Like, geez, that guy's in the road. Uh, Meanwhile, at this gore point, there's a pickup truck with a trailer that decides that even though they're on the right-hand side of us as the thing's splitting, they want to be on the other branch. And
mm,
so they zip right in front of the truck at a last moment, do the New Jersey slide and go take the exit. And fortunately, the truck was driving, the Aurora driver was driving because it's able to both pay attention to that critical person on the side of the road and also see all the rest of the traffic. And so it has already started to brake because it anticipates this pickup truck making this move across in front of us. And so like that kind of kind of very anecdotal bit is part of that kind of full field of view, but fully attentive and sharded intellect that we get that brings safety. So that matters to customers, and that matters both in terms of kind of the morality of being safer on the road, but also in terms of their insurance costs,
right.
right, and the impact that that has to their bottom line. A second part is fuel economy.
Mm,
So we expect to, and we've got a white paper published on this, to be able to save between 14 and 34% on fuel efficiency or fuel economy for these vehicles. And again, um, that's a big deal. Like fuel historically has been top three in the cost structure for these vehicles or for these companies, particularly with kind of the ongoing current geopolitical dynamics. It's going
right.
up. And so this is a big deal. And then, of course, that's good for the environment,
Right.
right? This goods need to move being, 14 to 34% more efficient means 14 to 34% fewer emissions. And then finally, access to drivers. So anyone who is um, willing to drive a truck, we should say thank you to. If you look around the room you're in, the room I'm in, literally everything here moved on a truck. Our economy would cease without trucks. At the same time, uh, we don't have enough people who want to drive trucks. Over the next decade, we expect to be short 1 million truck drivers. And so for our customers, being able to get access to a scalable pool of drivers to complement, and importantly, to complement the people they have driving trucks is critical.
Right.
And so, we see this as a way to help them power their businesses and to kind of continue to grow the economy over the coming decades.
I see. Let me pick up a couple of things. Well, you said quite a
Sure.
bit on
Yeah,
that.
sorry.
So no, the first one, yeah, to what degree this may impact this short haul and medium haul flight freight, right?
Yeah.
Previously, it's out of the range of the human driver, but now
Yeah.
it's within range. For example, the Fort Worth to Phoenix, for example, right? How much do you guys have done some calculation on this?
Yeah, we started to look at this loosely, and there's two ways that it helps. So there's some places where our customers just can't get drivers, and so they put it in air freight, and that's just expensive. Um, I like it's dramatically more expensive. But yes, I think this kind of mid-range air freight is one where automated trucking is going to quickly win that business. And this comes in particularly relevant around the holiday shopping season.
Mm,
So, you have some bit of consumer electronics that is really selling well in San Francisco and is not selling at all in Houston. you need to effectively overnight move that from your store in Houston to San Francisco. Otherwise, you are missing that shopping window and you're
Mm.
stuck with a bunch of unsellable inventory. If you stick it on a plane, which is kind of what you do today, it gets there tomorrow.
Mm.
But you've lost most, if not all, of the margin.
Right.
Uh, if you stick it on a truck, it gets there in 3 days and you've missed the window. If you
Mm.
stick it in an automated truck, it gets there tomorrow
Right.
and you now have
You got
most of your
captive
margin
market.
still. Yeah.
Nice.
And
Right.
so like that becomes a really interesting impact there. And then when you think about the footprint for uh, when you think about the footprint of distribution centers, that's one thing where, again, they're based around kind of the human distribution network. And so we expect that real estate market will shift substantially as well.
Interesting. Yeah. Oh, the other aspect is about the powertrain. The in passenger cars, almost all AVs are also EVs or battery based, right?
Yeah.
In truck, that's not the case yet. Where do you see this the energy source will evolve?
Yeah. The Aurora driver is agnostic.
Yeah.
The practicalities of long haul trucking today are that the batteries are for kind of significant range are heavy enough
Mm.
that it actually impacts the payload you can pull. And for certain kinds of goods, you cube out before you weight out. But for
Mm.
lots of goods, you're bounded by the weight of the trailer or kind of the gross vehicle weight of the whole system. And
Right.
so that's one of the real detriments for long haul trucking for batteries today. We'll see where things go with fuel cells. We'll see, as we get to solid state batteries, which are potentially lighter. It'd be great to have this electrified, but today it's practically
Yeah.
not useful for long haul freight.
Right. Yeah. And last maybe on this portion about the different possible business model, right? So Aurora offered the driver as a service to the trucking companies, right? Versus other possibilities like Bot Auto, they become a trucking company themselves, right?
Yeah.
We also have a YB, Torque. They all give us the different possibility of business model. It's hard to say which one right or wrong, but why you choose as a driver?
I can tell you what's right. It's the one we're in.
Tell us
So,
your right.
yeah, maybe what I'll do is I'll tell you why we think. So our model is to work with the ecosystem rather than try and, change the ecosystem substantially. So today we are actually a trucking company, right? We have a DOT number, we haul freight. We don't go out and bid from shippers. We basically use it as a way to kind of try before you buy
Right.
for carriers. So, while we have our own DOT number, we will haul freight for Werner for their customer or for Hirschbach for their customer.
Mm.
Why do we think? And so starting next year, we'll be driver's service, which means that our customers will buy a truck, they'll pay a subscription to Aurora, we'll get paid based on how we drive that truck for that customer. So why that model? So first, it allows us to be asset light, right? That we're going to be focused on what we can do best, which is build the driving capability, work with others, rather than having to figure out how to do all these other things. Because I'm a big believer, if you're a company that's been around for 50 or 100 years, you're an apex predator, right? That you have evolved over that time to be extremely good at what you do.
Mm.
It may not be what I do, but you're very, very good at that. And so whether it's Peterbilt and Packard or Volvo or Daimler Truck or International, right? These are companies that know how to build trucks. Let's
Mm.
go work with them, right?
Right.
Let's go help serve their customers and allow them to be more competitive in what will be an evolving market. Similarly, on the carrier side, if you're FedEx or Hirschbach or Schneider, like you've seen a lot of challenges. You've evolved your management structure, you've evolved your business model, you understand how this works. And so let's support you to continue to grow and deliver your business. And let's be proud of what we're good at, but let's have the humility to understand that we're not good at everything and then go work with others to go do that. And I think that approach has served us well. It has, like I said, a nice economic benefit that we end up, being asset light in the long term, which I think is a good thing for us because frankly, we're just not that good at maintaining and owning trucks. And other people have a lower cost of capital than we have. And then the other is with this driver as a service model, it slots into the existing ecosystem kind of naturally, right? Today, they buy a truck and they pay a driver. And going forward, they'll buy a truck, they'll pay human drivers, and they'll pay the Aurora driver. And so it's a very natural kind of, alignment into their business.
I see. Yeah, last bit on the business about the insurance, right? In the prep, you mentioned that insurance company had been evolving all the time, dealing with all sorts of technology, right? How are they adapting to this autonomous driving?
Yeah, I think this is one of the biggest red herrings that people talk about. Like, oh, how is insurance and liability going to work? It's like,
Yeah,
we're in America. We'll figure it out, right? We don't have a shortage of lawyers. And so, like most obviously, there will be product liability, right? We're telling people we can drive this truck well for them. We stand behind that. At some point, if we're not, then, there'll be a legal proceedings that's associated with that. When we talk to insurance companies, like you said, they've been insuring things, some of them since the Mayflower sailed across the Atlantic, right? And if they had the same insurance product today that they had then, they wouldn't be in business. And so they've evolved with the technology over literally centuries in some cases. And so when we look at it, we talk with customers and we have what we think, what I can say in few words, which takes the lawyers a lot of words to say, which is if the Aurora driver is responsible for something that happens on the road that's a bad outcome, then we're responsible for it. If the base vehicle breaks in some way that was not supposed to, then that's on the folks who made the truck. And if the operator used the vehicle in a way or abused the vehicle in a way that's, kind of not appropriate, then it's on them. And it's kind of common sense, and insurance companies seem to understand that. And then around the insurance part itself, today we pay less to insure our trucks on a per truck basis than our customers do because of how seriously we put safety, how we can demonstrate that, it's real. My expectation is ultimately that, insurance in this market will effectively collapse to, the loss rate plus epsilon, because we're going to be able to, very clearly predict the loss rate. And so, the margins on that will collapse like they do in anything else where you have very good insight and understanding.
Thank you. Yeah. So in the last 10 minutes or so, let's move to the society, the policy, the regulation type of discussion here, right? One thing during practical instruction, we said, I mentioned the federal policy and the chaotic situation about the federal, state, or different things. You said federal policy for you is a friction, but not a barrier.
Yep.
Elaborate on that.
Yeah. Boy, it would be nice if there was one set of rules that applied everywhere. That'd be great, right? You wouldn't, it would constrain the conversation, and it would allow us to, have a consistent set of operating rules. That's not the world we live in today, right? And because our technology straddles two regulatory regimes. In the U.S., the federal government regulates the safety of the vehicle, and the states regulate the safe operation of the vehicle. And so since we're building an automated driver that's part of a vehicle, we're kind of in both worlds. And so we have to comply with FMVSS, and then we have to work on the state level around the operation of it. The good news is the majority of states in the U.S. today allow automated vehicles and automated trucking. And we look at like the Sun Belt where we expect to be operating, by the end of this year, it's something like 50 billion vehicle miles traveled. So it's a gigantic market. And, right now we see freedom to operate across that, and we continue to see strong support from the various states in that region. So we continue to have conversations. We think it's on us to engage lawmakers and regulators at state, local, and federal levels. We've been doing that since day one. We've built, I think, a fair bit of trust with them over the years, trying to be, kind of an honest champion for the technology. And, it would be lovely, again, if there was federal regulation. We think that will create a more, make America more competitive on the global landscape. It will reduce some friction. And so we're very strongly in favor of a federal AV framework. But, we'll continue to build our business with or without it.
Yeah, thank you. So friction, not a barrier. That's good summary. The position here, right? So another commonly asked question is about the labor force impact here, right?
Yeah,
3.5 million truck drivers, etc. Just to give you some context, in Boston, for example, as of today in Massachusetts, there's a huge debate from the Uber drivers talking about the potential banning Waymo from coming to Massachusetts. Right. Yeah. So on that, tell us your thinking about this.
Yeah.
What the world evolve and how do we help this group of drivers? As you say, it's a very difficult task. Their life's
Yeah.
not easy, right? How to help this group of people transition? What's your vision on
Yeah.
that?
So again, let me begin with like, thank you to anyone willing to drive a truck. Right. It has been essential to our economy and it will continue to be. And yet, those people are 10 times as likely to die on the job. They have serious health issues. They spend time away from home and miss important events, right? It's tough. We see the initial, we expect the first place this technology is going to come to market is in the long haul
Right.
market, right? Hauling between metros. This is often the least desirable jobs.
Hmm.
And it's often kind of the hazing jobs for people that come into the industry. It's the one where we are able to do it directly, right? We're getting from A to B. Um, my expectation is a lot of jobs get classified as a truck driver, but they're doing much more than that. So the Cisco driver who's delivering groceries to the restaurant, they're not just driving a truck. They're a customer rep. They're a sales rep. They're helping unload the groceries, right? They're doing much more than just servoing a steering wheel down the highway. And my expectation is those jobs are going to be here for a long time, right? There's an immense amount of value that they're providing beyond getting the truck from A to B. I also believe that the demand is so large that if you are a truck driver today and you would like to retire as a truck driver, you will be able to. Right? There's just an insatiable appetite for us to be able to move goods across the U.S. And as we make it easier, I think it's Japan's paradox, that there'll just be more and more demand.
More demand,
Right? So I think there's like, I think that there's a real, a very high likelihood that if you work as a truck driver today, you'll be able to retire once you want.
Hmm.
That said, I also expect that the quality of jobs will get elevated. That, as you have these automated vehicles, we'll have more dispatch roles, we'll have terminal operations roles. These will be, maintenance and technology roles that'll be related to this, right? And that those will be places where folks who are interested in logistics can get better quality jobs that allow them to get home every day. And in Aurora, we've made $1 million commitment to in what we call Aurora Works to go out and help fund some of the job training programs to continue work that we've been doing for many years with folks like the Gallatin College um, in Montana, where we've been working to develop the next generation of LiDAR and optoelectric technicians, or what we've been doing in Texas with Over the Road Garage, where we've been again helping develop a technology program for technicians a training program for technicians to maintain automated vehicles. And what we did historically with Pittsburgh Community College, I think it was. Unfortunately, I think that institution went under, but we're looking for other opportunities to continue to invest this. Like I said, we're made $1 million commitment to do this.
I see. Yeah, I just learned that in the 60s when containerization was introduced in the port, right? At that time, actually, the labor union and the port reached an agreement. Instead of saying, oh, banning technology, we say, we welcome the technology in, but through that, the port put a designated fund to support the shoremen for their family life to transition in that generation.
Yeah. And it really depended on which port, which is interesting, right? And this is, I think, there's an interesting story here because New Jersey embraced containerization and New York fought it. And there's no longer a port of New York in practice but there is one in New Jersey. And there's a wonderful book called The Box, which is actually about the story of containerization, which sounds like it would be rough reading, but it was actually really quite. I read it on my vacation over the holidays. It was good, really good. So yeah, if you're interested in that, it's super interesting.
Oh, yeah. So give us, in 5 years, where do you see the whole industry will be, right? What will excite you as a very positive outcome for the society?
Yeah, I think we will make a major impact on truck involved collisions on the freeway, right? There's 500,000 of them every year, 5,000 fatalities related to collisions with heavy trucks. I think we can drive that down substantially. Substantial benefit in fuel economy, substantial, improvement in the rate at which goods are able to move through the network and get to customers. My expectation is in 5 years, if you're a trucking company not using the Aurora Driver, you will just not be competitive because of the advantages and the profitability we will get for those companies, or will benefit those companies.
Thank you. Yeah, maybe the last question. That's for more of the student, the younger generation who aspire to be entrepreneur or get into the field. You live through this, right? You're a researcher. You work for a corporation, and you're an entrepreneur. Tell us your experience going through the different phases and your advice to today's aspirational entrepreneurs. What do you?
Yeah, find something you find interesting. Right. So for me, I kind of stumbled into automated vehicles. It wasn't like I went to Carnegie Mellon. I was like, I'm going to do self-driving cars. Right. I went there thinking I was going to do legged robots. And I ultimately got into automated vehicles because I thought the idea of a vehicle driving across the desert at 50 miles an hour sounded cool. And over time, I first started to understand the immense benefit it would have to our young men and women in harm's way, and how more people died on the supply chain than on the supply line than the front line, right? And like, okay, that was inspiring. And then you start to understand the implication of this in civilian life, and the 40,000+ Americans who die every year on our roads, the immense number of families that are destroyed by it. Like, it's just a profound opportunity. I kind of stumbled into this and then kind of latched onto it. I've been, running with it 20 years. But I'll tell you the same thing I tell leaders of the company is I think that when we hire people, we need to give them a mission they can believe in. We need to give them work that is interesting, and they need to work with good people. And then we need to compensate them in a way that feels fair. And the reason for that is the first one is important because it doesn't matter how interesting the work is or how good the people are. Some days, some weeks, some months are going to suck, right? That's just the nature of life. And so, having a mission that's exciting, that kind of pulls you through that is valuable. And then if the work is not interesting in general on a day-to-day basis, or the people you work with suck on a day-to-day basis, then, it doesn't matter how good the mission is, you're going to go find something else to do. And then everybody wants to feel like they're treated fairly. And so, like, I think if you can find an environment where you have that, and whether that is at a university or at a corporation or starting your own entity, I think that sets you up well.
I see. Yeah, maybe the last question from me, I'll give it to John, is particularly since this year, this massive impact of AI, like vibe coding, this AI agent start to impact much of the jobs, and also at least the requirement of what's meaningful as a human to contribute, right? So what's Aurora's thinking on this? How much you are adopting into it? And given that, what type of competence you are actually looking for in this labor force?
Yeah. So I am a believer in this technology, right? That, when I look at how things like Claude Code have evolved over the last 5 months, even, it's almost day and night. It went from something that was kind of cute and interesting to, wow, this is really very useful. And what I've been talking to our team at Aurora about is this is probably the biggest change in how work gets done since the computer was introduced to the workplace. And at the time when the computer was introduced, if you could figure out how to use the computer, then it advanced your career. It allowed you to be more impactful and useful, and ultimately increased your employability. And that's going to be the same with this technology, right? That if you can understand how this can help you have superpowers and go forward, it will both allow you to be more productive and allow the entity that you're part of to be more productive. And so that's been our approach: is let's not look at this as a way to reduce our headcount. It's a way to, how do we give our people superpowers, and how does that help Aurora get where it's going more quickly and more confidently? And in parallel, making sure that our people understand how to use this technology. So whether they're with us and helping Aurora for the next 50 years, or whether they are moving to another career in 6 months, that they are positioned to go be competitive in the workforce. What do I think you need to be able to do? I think you need to be able to think at a systems level. This is allowing you to kind of get things done quickly, but you still need to think about how do they fit together? How does this influence the product? How do I actually make this into something that's actually useful? But if you are someone who wants to build something, I don't think there's just not a better time to be alive, right? What you can get off the ground quickly is pretty profound now versus any other time I can think of.
Right. Yeah, myself these days got addicted to white coding, but that's
Yeah.
on this.
I can tell you, like as the CEO of the company, I don't get a whole lot of opportunity to write code, and we have a very large code base, and so anytime I would think about, oh, I have this idea, the barrier to entry of me, like, okay, where does this live in the code base? What's the APIs? How do I like? What are the like? It just meant like, okay, I can't.
Yeah.
Whereas now I can
Just go
engage
to
with Claude and I can say, hey, I've got this idea. Give me like go do the research. What are the APIs you need? Where does this plug in? How does it work? And 45 minutes later, oh,
it.
cool. Okay, let's do this.
Right.
And it's allowed me to engage, our chief scientist, Drew, again, probably hasn't written code that landed in our code base for 6 or 7 years. Just, had an idea of how to solve a particular problem we were working on, was kind of out there enough that he didn't want to tell one of our employees, you have to go work on this. Right. So he like played with it over a weekend. It was like, and now it solved that problem and it's committed in the code base. And so it's just it gives you a leverage that you would not have had in the past.
Thank you, Chris. Yeah.
Okay.
Chris, we had a super active chat with a lot of actually really interesting questions. So we will share the chat file with you and your team. It's worth having a look.
Awesome.
But let me start with a cluster of questions that I think are related to what we could call the infrastructure or the future infrastructure of long haul trucking. So Sal Tannenbaum asked, in these city to city routes, where in the city are you navigating to, inner city or warehouse on the outskirts? Are these facilities accessible from highways? Similarly, Rabbi Mishalani asked, how does the technology work during the first and last miles on local roadways, that is, on the way from the origin, etc.?
Yeah.
Ellen Partridge asked, what kind of changes do you see for transferring freight from trucks on highways to trucks going into urban areas? Will additional labor be required to transfer from driverless highway driving to different trucks in urban areas? And finally, Tony Henderson asked, how do you handle mid-route refueling? So this is all
Yep.
about kind of this future
Yep.
infrastructure, transfer stations, things like that. Where do you see this going?
Yeah. So the good news is the freight industry deals with this today, right? It is super inconvenient and difficult to drive a long haul tractor trailer through downtown of any urban environment. And so what you see around most cities is industrial parks with distribution centers at the periphery. And most of those distribution centers are within, I think it's 80% are within 5 miles of a freeway. Please don't quote me on that number, but it's that order of magnitude. It might be 50% within two. It's anyway. And so we go from our customers' distribution center to our customers' distribution centers. And there we prioritize drop and hook, which means the truck comes in, finds a place, drops the trailer, truck gets a new trailer and heads out. And so that infrastructure is already there. So we don't believe in the get to the edge of the freeway, driver tucks and rolls off, and then somebody else jumps on when it gets off the other end. We actually do drive those miles that get you to terminals. And then the infrastructure is already there, and then it'll move generally to a smaller truck, whether it's a short haul or whether it's a box truck that'll get kind of to local centers. On the fueling, the first good news is these trucks have gigantic diesel tanks today. So, they'll have a range of 1,200 miles on some of the long haul things. So that's, you don't have to do a whole lot of fueling. But my expectation, and we're already starting to develop this, is that, there'll be a network of truck stops that are places where automated vehicles can pull in and fuel up. And so, the truck will text ahead or send a message ahead through our tooling to the attendant at the truck stop, say, Aurora truck 1725 is coming in. Here's the fuel card, fuel it up. And then, they'll kick it on the way out the door again after that. So, probably a boring answer. but practical.
Yep. Yep. Early on in the discussion, there was a clarifying question from Stephen Still, which is, are these commercial operations with or without a safety attendant behind the wheel?
Yeah.
Before you can answer that, but more broadly, Chris, how should we think about this question of safety attendants or safety operators or person in the driver's seat but not driving the vehicle or
Yep.
person in the passenger seat? I think there's a lot of general confusion out there. How should we think about it?
Yeah. So I'll tell you, so today we operate two fleets of vehicles. So we operate development vehicles where we are expanding the place the vehicle can operate. We're adding new capabilities. We're improving existing capabilities. Those vehicles we operate with a safety driver. And the role of that person is to ensure that the motoring public and themselves are safe on the road. Right. So they're attentive the full time. Their job is to make sure that everyone's going to be safe. And that's part of the development operations. Today, we operate additionally a driverless fleet. And in that driverless fleet today, we have an observer on the truck. And that observer is there because one of our partners asked us to have them in. Beginning in Q2, we expect to begin operating trucks without people on board at all. Is our expectation, or at least with the capability of operating without people on board. And so if you go to youtube.com/@Aurora driver, you can click on a live feed where you can actually just go watch our trucks live on the road day in and day out. I think we run it from 8 a.m. to 5 p.m. Central Time. Just see it. And I think we've got some nice soothing music. And it's super boring because that's kind of what you want.
Yep. And just to clarify, the observer is in the driver's seat or in the passenger seat?
They are sat in the driver's seat today.
Okay. All right. Sal Tannenbaum asked a question about the long distance LiDAR that you referenced. Is that proprietary or other AV solutions? Are other companies using it? Is this something sort of unique to Aurora, that long distance LiDAR?
Yeah, this is a very proprietary bit of LiDAR. Most LiDAR is effectively DC coupled or is AM, right? In that it's a pulse goes out, bounces back, and you measure the time of flight. We are doing FMCW LiDAR, which is how does we basically interfere the outbound and the inbound wave and measure the phase difference that allows us to do Doppler things. This is proprietary stuff that we own and others don't have. There's another company called AIVA that's trying to do something similar, but it's we think several generations behind where we are.
Okay. Glenn Shore asked, how well do these systems do in snow and ice?
So today we haven't validated them for snow and ice. That's outside of the ODD, and so we have constraint or restrictions that avoid it from operating in those conditions. But by the end of the year, we expect to be operating in those conditions, and this is an important distinction. So, a year ago, you would have gotten one of our trucks in a pouring rainstorm, and it would have worked. Right? You would have ridden along and said, okay, this is good, ship it. That's not our bar. We have a very extensive verification validation process we go through to get to conviction that it doesn't just look like it works, but that it actually works. And so I'm pretty convinced that if you put our truck out in the snow and on the ice, it would work. But we have not done the work on verification validation that would allow us to feel confident to put it out there yet. And so we don't. And that'll be the kind of thing that today we would be running with a safety driver because it would be part of gathering data that we would need to ultimately validate and verify that. Except by the end of the year, I expect we'll be operating in light snow and in those kind of conditions.
Finally, Chris, just a question from me, actually. I remember sitting in a room with you in Davos, Switzerland, about 10 years ago, and the CEOs of the automotive industry were there. You were with Google, and they asked this question about the trolley problem.
Yeah.
Basically saying,
we're bringing that up again, are we?
How is autonomous mobility going to deal with this? And
Yeah.
you had, I think, really the most compelling answer, which is people don't deal with that well, right? And so my question for you is, And it came up in another forum we did recently with Carl Yagnema. Why do you think we have this expectation of perfection from robotics, from this type of technology, when, as you just pointed out, more than 5,000 people are killed on US roads every year in an accident involving a Class 8 truck, which, by the way, I mean, that's more than 12%. And, they certainly Class 8 trucks do not account for 12% of the fleet. Of course, they account for many miles. So this is a terrible safety issue. How do you think about, how we make decisions as people?
I will start by saying I am not a sociologist or psychologist,
Yeah.
right? And I'm a technologist and an entrepreneur. And my approach is we see something that has so many benefits that we should work on this, and ultimately society makes the decision whether we accept it or not. And so what can we do? We can help educate. So as a anecdotal source, we looked at all of the fatal accidents that involved heavy trucks between 2018 and 2022 on I-40, where we were initially launching. And we created simulations of those events based on police reports, and we asked what would have happened. And what we found out is that none of those events would have occurred, right, if the Aurora driver had been the primary driver. And one of the ones that stuck with me is two light vehicles had a collision, a fender bender, and were stopped in lane, and the people had got out and were, I don't know, talking, exchanging information, whatever they were doing. A truck comes along, reacts late, swerves onto the freeway or onto the shoulder and drives through them, right? And of course they're killed, and it's awful. Just horrific. You run the same simulation with the Aurora driver, and what happens is the truck slows down and moves over, and everybody goes home. Right. And so I think one of the things we have to do as an industry is both look at the statistical evidence so that we are not creating an unreasonable risk on the roadway, and that we are advancing safety and we're doing those things. But then it's also on us to help create the relatable story, and fact-based relatable stories that allow people to understand the practical implications of it. Because you do have this, the anecdote happened to me and I can relate to it. The statistics happen to all of us, and so there's a diffusion of it.
Yeah.
So there's just that disconnect there. So the more we can do to act responsibly, develop the technology safely, deliver it, and then help tell the story as we introduce it, I think is what we can do. And then it's up to society to make decisions, and we elect people to do that. And I think everyone does their best.
Yeah. So sorry to cut into this. It's already 1 o'clock. Chris, thank you so much for joining us. This is really a wonderful conversation we're having.
Pleasure.
Everyone, please join me. Thank Chris for today's forum.